Mike here. So manufactured ice update. Did a video yesterday and just thought I'd show a little bit of what I've been learning. It's kind of ridiculous what I'm trying to do here. It's very simple. It's cold outside. I just want to make a big block of ice. And one of the issues with that is the heaving of the ice. Now, this whole project initially started because I wanted to mess around with two-phase thermosiphons, which help to transfer the heat out of the core of the block through the insulation of the ice itself, and help to increase the surface area of the volume. And really, if you think about this, I want to make big blocks because big blocks have limited surface area. So they melt slower, so they'll keep throughout the year. If I want to amass 50 of these blocks, and I want to store them in a little insulated hut, I want those suckers to last, so they have limited surface area per unit of volume. However, that also makes it difficult to produce the ice. If it gets sufficiently cold outside, the whole sucker will freeze in a relatively short period of time. But if you don't get those low temperatures, it's difficult to get it to freeze. So we increase the surface area, at least temporarily, with these rods, these half-inch pipes that have propane in them. And then we can pull those out and then top it off with some water, let it freeze shut, whatever. Pretty simple. So this particular test was just something I did last night, yesterday afternoon. I had one much longer one that I was testing in a previous video, and it was working pretty well. So I actually took that one and I split it into two that are roughly the same, both with fins on them, if I so desire. It's laying over there. But I said, oh, what the hell, I'll just take one off, leave the other one on. Well, what actually ended up happening was the one that had the fin on it hardly produced anything at all, because I think it either leaked or there wasn't a sufficient charge in it. So it's not a good experiment yet. But the one that had no fin on it at all probably produced about an inch radius of ice. So I'm guessing with the fin it's going to do a little bit better, but we haven't established that for sure. The other test that I was doing, previous video, I was discussing trying to relieve the heave, relieve the internal pressure that happens whenever this starts to freeze top, sides, and bottom, and it starts to squeeze the water and air that's remaining in the center, and then ultimately fractures because the water is incompressible, leading to all this heaving and stuff. So I was messing around with putting these pipes in, and then they extend down in, and it pushes water up, and prevents it from heaving. Well, they work till eventually they freeze, and then they will push up out. In fact, this was this pipe, which was down in pretty deep, and eventually it pushed all the way up until it pretty much, I had to bust it off, but it was pretty much right at the surface. It pushed a tube right out. This pipe is basically out, except everything is frozen, and it no longer was sufficient to relieve pressure. It's actually fractured and split and heaved, and it's not working out too well. This was a block that's been freezing for a few days. It's probably just about fully frozen by now. I've done a lot of messing around. Here's just a regular copper pipe, which does amass some small amount of ice around it, but thermosiphons seem to work better. This actually just drilled a 5/8 inch hole and stuck a piece of PEX in there. And it did weep for a while until, of course, it froze shut. And so this has continued to heave and fracture and got all white and stuff. This being one that I just put out yesterday, it's already starting to freeze from the sides, top, and bottom. And it is starting to heave, even though I put this insulated pipe on, which did continue to push water for a while. Now, I suppose I can make it longer with more insulation on it. I'm not really sure how I'm going to proceed at this point, short of putting a circulator, pump, or stir or something, in which I'm really avoiding doing. Something I could consider doing is insulating the top. If I could insulate the top, I could probably help to prevent the top from freezing so quickly, allowing for the expansion to just cause the water level to rise, cause the water to push up through whatever tiny fractures might occur in a thin layer of ice, and prevent the bulging that inevitably occurs to the container and the unevenness of the surface. I mean, this little bit of roughness, it's not really a big deal. I don't care about that, but eventually it heaves and cracks like this, and it's not going to come out of the pan in one piece. In fact, it's going to come out looking something like some of these. Didn't work out too well. Or doing something stupid like that where it just explodes, you know. So, you know, here is an example where I just thought, well, I'll start with a new container here, put some water in it, put a little 3/4 inch PVC pipe in it. Seemed to work fine for a while. It was getting nice clear ice, and then eventually froze shut. So I'm sure there's a simple solution to this that I will be aware of here in a few days. So I'm going to continue messing about with it, and I will pull this one out after I cut a little firewood here this morning and go ahead and repair it. It's going to be warm for a few days, so I'm not going to get a whole lot done with this stuff, but it'll be interesting to watch some ice sit here and maybe slowly melt. This device here, I'm going to try to get that out. If it gets above freezing, I'm probably going to turn it upside down, see if ambient air and or sun is enough to, you know, reverse the operation of the thermosiphon and just melt and dislodge that. You see, I did break it yesterday. I was twisting on it and it fractured at the bottom. And a commenter suggested, you know, heating it up, putting electric resistive on it. If I were to do anything like that, I would design the system in such a way that I could invert everything so that, like I said, it reverses the operation of the thermosiphon. If I start to heat this copper right here, eventually I will be able to probably melt and dislodge this, but the majority of that energy, I would imagine, is going to end up being transferred to the rest of this copper. If there's any liquid refrigerant in the vicinity at all, that's going to absorb a lot of that heat, and it's going to rise up and condense, fall back down, hit that hot copper, go right back up, you know. So it would be best, I think, to probably invert it, but it's not really my primary interest or primary goal for removing these things, if I use them at all. And there's a fairly good chance that if I can relieve the pressure of heaving through directional freezing or something, I'm going to end up using like a 2.5 inch pan like this, but a long one, such that I could freeze, you know, 3 of them relatively easily at night to equate approximately to this 6-inch pan, and then stack them with a, you know, wet them in between and stack them, let them freeze together, put them all inside of a big pan and fill it full of water and let it finish freezing. I don't know yet, but a lot of different options I could take. So, all right, thanks for watching.